Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem of quantum mechanics. Problem having been chosen from the book Quantum Mechanics Concepts and Applications. Author is Nordine Zetley. Okay, as usual, we first come to its statement. Okay, when light of a given wavelength is incident on a metallic surface, the stopping potential for the photoelectrons is 3.2 volt. If a second light source whose wavelength is double that of the first is used, the stopping potential drops to 0.8 volt. From these data, calculate part A, the wavelength of the first radiation, part B, the work function and the cutoff frequency of the metal. Dear students, we have solved several other problems on this topic, but mostly are on main channel physics lectures by Rajput Abdul Wahid Bhatti. Okay. However, on this newly launched channel, Quantum Mechanics by Rajput Abdul Wahid Bhatti, there is a inadequacy of such lectures, such problems. Okay, anyhow, if this video goes longer than 15 minutes, then we will have no option but to upload this video on our main channel under title Physics Lectures by Rajput Abdul Wahid Bhatti. However, if duration of this video remains less than 15 minutes, then definitely it will be uploaded on the concerned channel, that is Quantum Mechanics by Rajput Abdul Wahid Bhatti. Okay. So first we come towards a solution of the problem, in which an attempt shall be had to develop a foundation regarding the understanding of the solution. Okay, we know that h nu is equal to hc over lambda equal to work function w plus kinetic energy k. This implies that k is equal to hc over lambda minus w. Okay, where h nu is the photon energy, in which h is the Planck's constant and nu is equal to c over lambda is the frequency of photon. W is the work function of the metal and k is the kinetic energy of the electron leaving metal. Okay, so we will use this expression to solve some part of our problem. Okay, in this expression all things have been explained. Okay, that what is what. Okay, I think it is now relatively easier to understand. Okay, now we move towards the second expression which will be used in solving this problem. Okay, this stopping potential Vs, where S is written as a subscript of V. Okay, this stopping potential Vs is connected to the electron's kinetic energy by E into Vs mod, that is magnitude of Vs, magnitude of stopping potential, absolute value of stopping potential. Okay, equal to half mv square mev square, where E is written as a subscript of m and m stands for mass electronic mass. V square equal to k. This is equation number, we designate this expression as equation number 2. Using equation number 2 in equation number 1. Okay, using equation number 2 in equation number 1. Okay, this is equation number 1 and this is equation number 2, and now we are going to compare these and adjust equivalent values. Okay, then Vs will become equal to hc over lambda minus w. This implies that Vs will become equal to E will be divided on other side of equality, and hence HC over E lambda minus W over E. Equation, we designate this expression as equation number 3. Now we move further and develop two further equations which will be solved in this problem. Okay, let lambda 1 be the wavelength of the first radiation and lambda 2 be the wavelength of the second radiation. Then according to given condition, second wavelength is double the first wavelength, so definitely lambda 2 will be equal to 2 lambda 1. This implies that equation number takes the form as, okay, in equation number 3, once we will use lambda 1 and then we will use lambda 2, that is value of lambda 2, which in terms of lambda 1 is 2 lambda 1. Okay. So stopping potential of first radiation becomes equal to Hc over E lambda 1 minus W over E. Stopping potential of second radiation becomes equal to Hc over E into 2 lambda 1. Okay, lambda 2 is equal to 2 lambda 1. So minus work function W over E. We have designated these two expressions as equation number 4 and 5. Okay. Now students, in order to reach our desired parameters, one time we will add these two equations and one time we will subtract these two equations. Okay. Now quite simple. By doing so, we will quite easily reach our desired solution. Okay. Subtracting equation number 5 from equation number 4, we get stopping potential of first radiation minus stopping potential of second radiation equal to Hc over E lambda 1 minus Hc over E 2 lambda 1. Okay, here lambda 2 does not appear, in place of lambda 2, 2 lambda 1 appears. Okay, now we will take common Hc over E lambda 1 and it will become equal to 1 by 1 by 2. This becomes equal to this. Okay, just simplification. So however, I see whether we have placed a table where value of Hc is given. Okay, we go at the end of this problem. Yes, Hc. Okay, value of Planck's constant H separately is also given in two different expressions, and combined value of Hc is also given. Okay, so from this table we will use the value of Hc. Okay, Hc. Yes, here in place of Hc we will use that table and put the value of Hc. Moreover, we can also take the value of E, but we do not need this value because this expression will be cancelled out. Okay, otherwise value of E is also given in that table. We see at the end here value of E is also given. Okay, but in this case we do not need to put this value because here E will be cancelled with E. In the E in the numerator will be cancelled out with E in the denominator, and hence lambda 1 will become equal to this. Okay, this nano stands for 10 raised to the power minus 9, and hence our lambda 1 becomes equal to this, or it can alternatively be written as 2.6 into 10 raised to the power minus 7 meter. Okay, so one part has been solved. Okay, now we will add these two equations to reach the remaining part of the solution. Okay, part B. Now adding equation number 4 and 5, we get a stopping potential of first radiation plus stopping potential of second radiation equal to this. Okay, just simplification. Here small e, however small e will be cancelled with small e. Okay, so 3 by 4 minus e by 2. Okay, quite simple, nothing ambiguous. We have designated this expression as equation number 6. Okay, hence what we are going to do, we are just using values in equation number 6. Okay, hence work function W becomes equal to 3 by 4 into, this is the value of HC. Okay, nano stands for 10 raised to the power minus 9 over here value of lambda 1 we have calculated in our previous part. Okay, here moreover stopping potential of first is also given and second is also given. Okay, moreover value of E is also given in the table. Okay, so just in the next step here once again, dear students, we have not used the value of E because E will be cancelled out. Okay, actually here because these two are being added, one is 3.2 and one is 0.8, so both will be added and will become 4 volt. So here 4 electron volt. So it's quite simple. This is also in electron volt and this is also in electron volt, because 4 will remain 2 due to this 2 in the denominator, and hence work function W will become equal to this minus this, equal to 1.6 electron volt. Okay, in terms of electron volt, our work function has reached its final destination. However, there is also a conversion factor in this table, that 1 electron volt is equal to so many joule. Okay, so we can also convert it in joule, because when 1 electron volt is equal to so many joule, then so many electron volt will be equal to this into this joule. Okay, and after simplification we will get W equal to 2.5632 into 10 raised to the power minus 19 joule. Okay, so both these values are quite accurate and acceptable. 1.6 electron volt or 2.5632 into 10 raised to the power minus 19 joule. Now we know that nu naught equal to W over H is called the threshold cutoff frequency of the metal. So nu naught equal to W over H, so. After simplification it becomes equal to 3.868 into 10 to the minus 14 hertz. Okay, because dear students, here joule will be cancelled with joule, and second inverse 1 over second or second raised to the power minus 1 is equal to hertz. So frequency nu naught, cutoff frequency, threshold frequency will become equal to 3.868 into 10 raised to the power 14 hertz. And this is the end of our video. Till next video, Allah Hafiz.